We've seen quite a few examples so far about this completing the square business. Next step though, what happens if our coefficient on that squared term, that x squared piece, isn't a 1 or just a simply -1? What if it's some other number? Let's try example 3a. We want to complete the square of the function f of x is equal to 2x squared plus 12x plus 1. So the difference here is that I have a 2 in front of that x squared. We're going to start it in the same way though. We're going to begin by looking at our x terms, the parts that have x's, inside some parentheses. Leave some space. I know eventually I'm going to work with that space. And then our plus 1 is tagged along there. So the key for these types of problems, and we did this with our negative sign, this x squared needs to be a positive 1x squared. We can't have a coefficient here other than a positive 1. So that 2, I need to factor it out from my parentheses here. I'm going to take that 2 out from both pieces. So if I factor out the 2, that's going to leave behind inside my parentheses x squared plus 6x. So we have the right form now. We have a nice positive 1x squared inside my parentheses. And here comes the completing the square. My b value will be that 6 divided by 2. Once again, don't take the variable, just the number, just the coefficient. That gives me a 3, but I need to know what that 3 value is squared, and that's a 9. So the magic number I need to add to make this work is a 9. But I have to compensate for it. I have to make sure that I'm not changing the function. So notice I don't have a negative, but I do have that 2 in front. So in reality, when I say I'm adding 9, I'm actually adding 2 times 9, because that 2 would be applied to that 9 as well. So if I'm adding 2 times 9 on this part of my function, to make up for it, I need to subtract 2 times 9. See that? We got to be careful with those coefficients. We got to think about the parentheses and the operation that's really being shown here, right? It would be a multiplication all the way through. So a little adjustment, but we got to make sure everything is still balanced. Again, we multiply that 2 times the 9 really in this, but by writing this over here. So I got to subtract that same amount on the outside over there. From that point, it's a matter of factoring, and I think we're okay now. Maybe we can jump to the factored form. We said this is a nice perfect square trinomial. The value for b is always that number we got after dividing by 2. So I'm going to write x plus 3. And then out here, let's see what we get. We have 1 minus 18, because 2 times the 19 is 18. 1 minus 18 is a negative 17. And there it is. There's our answer. So the more we work with them, right, the more we have to see different situations. That's always important. But the faster we can get on some of these steps, right? Just a little bit of experience gets us going a little bit faster every time. Let's try one more. Still example 3, but let's skip to part C. So on part C, we have f of x is equal to negative 5x squared plus 50x plus 30. So we can see how this one kind of has everything in it. We have a negative, we have a coefficient in front of that x squared, and we have some other values as well. But we're going to start in the same way. Let's group the parts that have an x somewhere. 50x plus 30. Keep that on the outside for now. Then we want a positive 1x squared here. So I need to factor out the negative 5, not just the 5, but the negative as well. So if I factor out a negative 5, I'm going to end up with that positive x squared that I need. But negative 5 taken out from this 50, right, the 50 divided by negative 5, will give me a negative 10x plus that 30. Okay, so we factored out the 5, we factored out the negative. To get this x squared, that's the only way this process works. Okay, now let's go to the process. Let's take that b value. In this case, it's negative 10. I take negative 10, I divide it by 2, and that's going to give me a negative 5. But I also need to know the b value squared. Now watch for this here. It's a negative squared. A negative value squared will always be a positive number, right? Negative times a negative will give me a positive. In this case, we get a positive 25. So it looks like in here, I'm going to add 25. But thinking about the parentheses and where that 25 is placed, it's not just a simple plus 25. I'm actually adding that negative 5 in front times that 25 on the inside. That negative 5 would be distributed all the way through each term. So this is what I'm really adding. So to make up for that, I need to subtract negative 5 times that 25. I need to subtract that same value. If I add it over here, I need to subtract it on the other side. So then, let's see what we have. F of x will equal negative 5 parentheses. If I'm ready to factor this, I can. I know my term starts with an x. It's going to be squared. It's always that b value that we get after dividing by 2. So in this case, it's a minus 5. Careful with that minus. It does go along with our notation. I'm going to need a little extra work over here, so I'm going to put an extra step. I'm going to put the 30, and then let's calculate this. Negative and a negative will give me a positive. 5 times 25 is 125. So that's a little nicer, and then I can add them up. We have then the function is negative 5 open parentheses x minus 5 close parentheses, all of that quantity squared, plus 155. And there's our answer. So the key, right? A couple of things as a takeaway. Always is just the number divided by 2 and then you square it. That's what you're going to add or subtract. You have to make sure if you factored anything out from the beginning, because this only works if you have an x squared. If you factor anything out when you're doing your adjustment for the addition, you got to make sure you're subtracting the right numbers, the right quantities. And then, as a matter of factoring, it's pretty straightforward to get to that final version. And if you're ever uncertain of your answer, you can always check by using your distributive property, expanding this out. You should end up where you started.